In my first expert video, I touched on how information and computation were important elements of computer science to me. So in your first session with the microbits, I want to use them as devices to collect information from the world. We'll also use some logic, some if-then statements to manipulate the information that they've collected, a form of computation. This particular task, in terms of the Wyoming domains, focuses on computing systems, devices, and data collection, which is part of the data analysis domain. It will also touch on aspects of algorithms and programming.
Let's start, as this may be one of your first times using a microbit, by looking at some of the options that are available for getting information into the device. If you click on Input, you'll see lots of ways to prompt your device to do something. You can make it do something when a button is pressed, when it is shaken. The pins of your device over here, when one of these is pressed, you can make it do something. You can also trigger behavior based on outside information sensed from the world, such as when the device is accelerated, when it's tipped or tilted in different directions, the light level of the device, the compass heading, in what direction the device is pointing, the temperature that the microbit is sensing, and there are many more, such as the rotation, magnetic force, things you may use less often, but lots and lots of options. Beyond that, once you have information into your device, you're going to want to manipulate it. I called this computation. I mentioned it's to do with logic statements, if-then statements, decisions that have to be made. If you look under the logic drawer of your microbit, you'll see many options for manipulating your information if something is true or if something is not true. These typically in computer science are embedded in if-then loops or if-then-else loops. If-then meaning if a certain condition is met, then you're going to execute some behavior. The else block allows you to say, well, okay, if that behavior isn't met, execute some different result. You don't have to just do this if something is true or false. You can make direct comparisons. You can execute some code if two possible variables are equal, if one is greater than another. You can even say if two strings, two words, two pieces of text are the same. And finally, you can combine conditions together. So instead of just saying, if something is true, execute some behavior, you can say, if both something is true and something else is true, or if either of two things are true. So these are the sorts of things we'll be working with today. Some other important inputs to your microbit are the more basic inputs that you might find yourself using all the time. For example, show number will display something, a number on the screen of your microbit. This would be the results of what you've done to your information you're manipulating. You can show some LEDs, you can display an icon, you can print words, print a string, show a string on the screen. And two things that are going to be important potentially all week are these blocks of code, forever and onStart. OnStart sets up initial conditions for your microbit. We'll look at it more in a subsequent tutorial, most likely if you're following these through in order tomorrow. Forever sets your microbit into a state where it will always execute your code of interest. So it's constantly monitoring on a loop and saying, okay, let's just keep going, and whenever the conditions that you've told me are true or false, if that's your preference, then I'm going to execute the code. So just constantly monitoring stuff in the background. In this tutorial, I'm going to ask you to play with the inputs to your microbits, so information, and if-then logic, so computation. Let me start with an example. So what I'm going to do initially is I'm going to program the microbit so that if it is tilted in a certain direction, it's going to play a melody, which is going to get quite irritating. I'm going to pick an annoying one. So you'll see that we have many of the aspects I've already been discussing. We're going to have a forever block. I'm going to irritate you by making this happen all the time. It's going to constantly check for the conditions to be right. We've got some computation, some logic block if something is true. This is going to be what I need to be true. We have my input. To measure the tilting of the device, I'm going to use this acceleration. The x here means in a specific direction, but you can actually measure the acceleration in lots of different directions. And finally, what I haven't really touched on yet, is when I take my information, my input, and I manipulate it with some computation, I'm going to have to display the result somehow. Often we'll just show something on the screen of the microbit, but for this example, I'm going to play an irritating melody. So let's watch how I set this up. First of all, I'm going to choose my irritating melody. Currently, the device is just set to play nothing, but let's choose something quite simple. So I'm going to, you can hear these tones, set up a descending tune as follows. If you want to know what this will ultimately sound like when played, you can play it, and here's what you'll hear. So already, I'm sure you can agree, quite irritating. So let's get back to the problem at hand. When the microbit is tipped, I want it to play this melody. And I want it to just monitor constantly to determine if it has been tipped in a certain direction. So, for example, let's get going. It's an if something happens. And how am I going to say if the microbit is tipped? Well, if it's tipped, this acceleration in a certain direction is going to change. And how much does the microbit have to be tipped before a result happens? I've chosen 800. When the microbit is level, it's at 0, and when you tip it, it can get as high as a number of 1024. I've chosen 800. I could have chosen 1000, doesn't really matter. So if this happens to the device, so I'm going to put this in the if-then block. Here's my computation. Then I want some result, and I'm going to play a melody. You may notice that currently this block is grayed out. It's got crosshatches in it. The microbit doesn't really know when to do this yet. And this is where the forever block comes in. I want this to happen by, in terms of the microbit monitoring the device at all times. And whenever these conditions are met, it's going to happen. It doesn't have to be forever. You may remember in the basic block, there are options such as, not in the basic block, in the input block, there are options such as when something happens. I didn't have to do this forever. I could have just done it when button A was pressed. When button B was pressed, you can change this to button B. When a pin was pressed, or when some external conditions were sensed, such as a compass heading changing or light level changing. But for now, let's just do this forever. Again, input information to my code is the acceleration of the device when it's tipped or tilted at a certain level. The condition, the computation, my logic condition, my decision, if this happens, then, and the result, I'm going to play some annoying, irritating melody I've chosen. So let's see the results of this over in the emulator. I'm going to start this, and you'll find you get irritated very, very quickly. I will attempt, I didn't get it, I didn't make it, but I will attempt to not tilt the device. You can see as I move this way, the device is tilting to the right, and as I move this way, it's tilting to the left. And you can see the acceleration in x goes negative as I tilt to the right, and positive as I tilt to the left, and positive as I tilt to the right. As I tilt forwards and towards me, the result is really happening because I'm tilting left and right. But if I had a steady enough hand, hold things in a plane, I could choose a particular direction and the acceleration in the x direction wouldn't change much. So for example, if I can run right up the middle, it would stay at 500 because I'm not moving in the x direction at all. I'm not very good at that, but trust me, tilting forwards and backwards without tilting it left or right is not going to affect the x acceleration. I guess in this emulator you have to do something a little like this, but in any case. So notice that I can tilt as much as I want to the left, negative values, nothing happens. My input is changing, my acceleration in the x direction is changing, but it's not resulting in anything because my logic says, my computation says, only do this when something changes in a specific way. I have to get my acceleration to 800, here it comes, brace yourselves, and then I trigger my melody, I get some output. The important thing here is the information, the input to the device, which was the acceleration, and the logic. Okay, I have my input, but I'm only going to do this, my computation, I'm only going to make this decision if some certain conditions are met. So what I want you to do in today's session is play around with getting inputs to the device and using if-then, using logic statements to get the result in question, which I'll tell you. So I have 5 specific tasks I'd like you to address. First, I would like you to set up the microbit, you can check if things are working in the emulator, such that when button A is pressed, you show the temperature in degrees C. And you're going to show it 3 times. So I want it to scroll across the screen 3 times. Your second task, when button B is pressed, I want you to show the temperature. And notice under basic, you have show number here. To show the temperature in degrees Fahrenheit, what you might be more used to. To convert Fahrenheit to Celsius, you're going to have to multiply a number by 9/5 and then add 32. So you're going to need something from the math drawer here to multiply numbers. My third possible task, when pin 1 is pressed as your input, pin 1 over here, I want you, if the program has been running for 10,000 milliseconds, so 10 seconds, to light up this LED in the top corner over here. You can play around with LEDs using information in the LED drawer, and you can plot which LED using this plot XY command. That's the third thing. For the fourth task, when you shake the microbit, I want you to show the string help on the screen if the light level, the ambient light, is less than 50 or more than 100. And finally, if the compass heading of the microbit is between 90 and 270 degrees, then show an arrow pointing south. Else, otherwise, so this is going to require an if-else block. If the compass heading is not between 90 and 270, then show an arrow pointing north, pointing up on the screen. I don't think you'll get to all 5 tasks today. If you do get to all 5 tasks, fantastic. But do as many of them as you can. And I will use all 5 to give you more examples of how you take these inputs, your information, and make decisions, if-then loops about them, your computation. So I'll be back with the solution at the end.